Hello everyone, Plus2 here. We are doing level 3 integration 2024 today. Right. Starting with question 1a. Find integral 6 secant 2x tangent 2x dx. If you see formula sheet right here, secant x tangent x becomes secant x, right? So secant x, if you differentiate secant x, you get secant x tangent x. So backwards, if you integrate that, you get secant x. So knowing that, back to question. So, well, 6 just stays there, right? Um, secant 2x tangent 2x becomes a secant 2x over 2, isn't it? And then plus c. You shouldn't forget c. And 6 over 2 becomes a 3, and the answer is a 3 secant 2x plus c. Right. Good warm-up. B, the graph below shows the function y equals 40x bracket 5x squared minus 3 cubed. Find the shaded area. So obviously we have to integrate this function. Some of you, I'm sure you expanded and integrated. It would be too hard. We have to use a substitution method. So let u be 5x squared minus 3. Then instantly you differentiate it because you have to find the du, right? So du dx is a 10x. Hence dx is du over 10x. And then to rewrite this, the 40x 5x squared minus 3 cubed dx becomes 40. X is still there because you see x. So, automatically you can cancel out x, which is great. Without that, you can't, right? So this is like a perfect combination. And then 5x squared minus 3 is a u cubed and du. So what left is just integral 4u cubed du. I didn't change this range. You don't have to. So I just didn't write there. And so that means 4 is outside bracket. U to the power of 4 over 4, isn't it? So 4 cancels out. And u is originally 5x squared minus 3. And then to the power of 4, right? And then I can put the range back or domain, whatever you call it. So from minus 0.4 to 0. So when you plug them in, you get 57.57 of, yeah, 57.5744. All right. Next, an object's velocity can be modeled by the equation Vt 26.4 cube root of t, where v is the velocity of the object in meter per second, and t is the time in seconds since the start of timing. Initially, the object was 360 meters from a point P. Calculate the distance that this object has traveled from the point P when it has reached a velocity of 264 meters per second. So you have to integrate velocity to get displacement function, right? So if you, well, first of all, you have to change cube root of t into index form, which is t to the power of 1/3. And then you integrate it, right? And then you get that, right? And then to find the c, you have to plug 0 because it starts from 360 meters from a point P. So c must be 360, right? So you get this nice yeah, equation here. Then you have to find the time when the velocity is 264. So back to the velocity function, you set this equation, right? Then it comes out t is 1,000. So 1,000 seconds later, what is the distance is the question. So then you plug 1,000 into the displacement function over here. You will get 198,360 meters from P. should be the answer. All right. Consider the differential equation dy dx and 24 cosine 3x sine x. I found in this exam there are many differential equation questions, and given that y equals 6 when x is pi over 3 to let you find the c, isn't it? And then find the value z of the when x equals pi over 2. I just it says s. So, uh, so there is possibility that the answers can be plural. So you split them, right? So dy equals 24 cosine 3x sine x dx, and then you put the integral sign both sides, leaves the y equals that and that and that. So if you don't really follow that, I suggest you pause and meditate on what I wrote there. And then you plug pi over 3 into this equation to find the c. So c comes out 7.5, and you complete the equation. But the question is when x is pi over 2. So you just simply plug pi over 2 to get the answer, negative 1.5. So it's one answer in this case. Okay, next. The graph below shows that the curve y equals 3 secant squared x and y equals 2 tangent squared x. To find the area in between 0 to 1, you have to take away, right, from top one to bottom one. So you can form this equation here. 3 secant squared x minus 2 tangent squared x dx from 0 to 1. Now, so if you see formula sheet, you could change the secant squared x, right? But the problem is you can't change tangent squared x. So I just figured it out. I thought, oh, well, secant squared x is 1 over cosine squared x, and tangent squared x means sine squared x over cosine squared x. So I have spotted you have a common denominator. So yeah, there must be a way. So I combined them and then I simplified. It's nicely done. So again, 1 over cosine squared is a secant squared x back, and that second part is just 2. So you split like this: 1 over cosine squared x and the 2 cosine squared x over cosine squared x becomes 2, isn't it? So secant squared x becomes just tangent x. You saw the formula sheet. And then 2 becomes 2x from 0 to 1, isn't it? Plug them in, you get 3.557. All right, question 2. Find the integral 3x to the power of 4 plus 4 squared. So this is the time you need to expand, right? So you expand it first and then integrate it. So you have to say plus c. Right, find the value of k given that. So this is a typical question. So you integrate 3x to the power of half, you get that, and from k to 16. So you form the equation. That equals 112, isn't it? And then, so 2k to the power of 3 over 2 becomes 16, k becomes 4. It's not a hard question. Consider the differential equation. Again, differential equation. Given that y equals 0.5 when x is 0, find the value of y when x is 1/3. So same as the previous question. 1 over y squared, isn't it? So you have to split the terms with the y and the leftover right-hand side. So when you integrate it, you get that, right? Because 1 over y squared means y to the power of negative 2, and you use a power rule to integrate. And that means 1 over y is negative 4 e to the power of 3x plus c. It seems like it should be negative c. It doesn't matter whether you say plus c or negative c. You will get the same equation. So it turns out 1 over y is that. So means y equals 1 over negative 4 e to the power of 3x plus 6. And what? When x is 0, oh yeah, you got c is a 6. So when you plug 1/3 into x, it becomes e to the power of 1, so which is e. So negative 4e plus 6. So you are finding 1 over negative 4e plus 6. That gives me negative 0.245. Okay, so I'm just saying y must be 1 over negative 4e plus 6. All right, next question. The graph below shows part of the graph of the function y equals sine squared x. Yeah. Find the shaded area enclosed between the lines y equals sine squared x, y equals 1, x is this, and x is that. So you see this is a symmetrical. So that means you just find the one part. So I chose 0 to pi over 2, and I double it. It's easier that way. So 1 minus sine squared x, isn't it? So y equals 1 is the top one, y equals sine squared x is the bottom one, so you find the difference. So you know 1 minus sine squared x is a cosine squared x, and cosine squared x is, yeah, cosine 2x plus 1 over 2. So you have to figure it out from here. Yeah. So cosine squared x equals what? Cosine 2x plus 1 divided by 2, right? So you have to use this identity. Now, so here, and then you can cancel out 2 and 2. So cosine 2x plus 1, and you integrate sine 2x over 2 plus 1 becomes x, and you plug a pi 0 and pi over 2. So, well, I just remind you, you have to plug pi over 2 first, right? And the takeaway when you plug 0. So the difference is just pi over 2. All right? Question E. This question, I would say, a challenging question, but still, you have to use the substitution method. I don't think there is any other way to solve this question. So the mass m of a spherical object with a radius p can be approximated by this, where a, b, and p are all positive constants. So you don't have to understand the formula, but you just need to, integrate this. So m equals to 4 pi. I'll just put 4 pi. I could put a outside as well because they are all constant outside of this integral. I mean. And then you have to, substitute r cubed equals u. I mean, before I did r cubed, I tried r squared. It didn't work, so I tried again r cubed equals u. So du dr is 3r squared. So that way you can cancel out r squared, right? So that's why r cubed should be u. So that means that r equals du over 3r squared. So r squared is nicely cancelled out. So everything is about constant and u, which is good. And here, 1 over 1 plus bu, well, it is, when you integrate f prime x over fx, that becomes natural log f of x, right? You just need a b, so there is no b, so you have to manipulate. So that's why I say b here and b there. Okay, so I'm talking about this, and then so 4a pi over 3b over that ln 1 plus b r cubed, because when you say u is actually r cubed, right? And then you plug p and 0. So when you plug p, you get that, and you plug 0, you get ln 1, which is a 0. So finally, you get 4a pi over 3b times ln 1 plus bp cubed should be the answer. All right, question 3. We are almost there. So find this. This is the question. Again, you have to change this to an index form, right? Like this, and then you integrate and make sure you put C. So this is okay, but I kind of have a habit. I avoid the negative index, so I rewrite this. So both are fine. Out the differential equation again, differential equation. So dy 5 4x minus 3 dx, and then well, this is a 5 over 4 and 4 over 4x minus 3. So, so this is related to our previous question. You know, integral f prime x over f x dx becomes what? ln f of x plus c, right? So that's the question, isn't it? So you get that, and then we know when x is 1, y is 10, so it turns out c is 10. Finally, you complete the equation, all right? In question C, find the value of m given that, so, this one, so you needed this skill set, so which is, well, denominator is 2x plus 3, so 4x plus 5 is 2 lots of 2x 3 minus 1, isn't it? So when you expand that, you get 4x plus 5. Then you split like this. It's a bit of algebra, isn't it? So 2 minus 1 over 2x plus 3. And then you plug m and negative 1. Before then, I split them because 1 over 2x plus 3 is actually, I can manipulate to 2 over 2x plus 3. Obviously, you have to times by half in front, right? So you get that, and then plug m and minus 1 into it, and make this equation, right? So that equals 2m. Hence, 2m plus 3 is e to the power of 4. Hence, m is, you can just leave it like this, e to the power of 4 minus 3 over 3. If you put them into your calculator, you'll find the 17.2, 1 dp. The graph below shows the function y equals 2 cosine x over 2. Find the value of k so that the shaded area A will be equal to the shaded area B. So first thing is you have to find the whole area, isn't it? Oh, you can because it's a 0 to pi. So you plug them in, right? And this is an easy bit. So you get the whole area being 4. So area A should be half of it, which is a 2, isn't it? So 0 to k is 2. So basically you solve it, right? Then you will find k must be pi over 3. Oh, well, you can change it to decimal, but I know that sine inverse half is 30 degrees, which is a pi over 6. Yeah, so that's why I made it exact answer, better way. And question is Newton's cooling law problem, isn't it? A teacher makes a cup of coffee at the start of interval. The teacher leaves the cup of coffee in the staff room where the temperature is 18 degrees Celsius. After 30 minutes, the temperature of the cup of coffee is 50 degrees Celsius. The teacher believes that the coffee is still too hot to drink. When the teacher returns again after a further 1 hour, the cup of coffee has cooled it down to a temperature of 30 degrees Celsius. The rate at which the temperature of the cup of coffee changes at any instant is proportional to the difference between the temperature of the cup of coffee and the temperature of the room. Write the differential equation that models this situation, and then solve it to calculate the temperature of the cup of coffee when it was made, meaning when time is 0, isn't it? I believe time is in minutes. So dt, so the rate of change equals to k, it shows proportional, right? T, I could say Tn, but I didn't, just T, the temperature of the coffee minus Ta, ambient temperature, right? So that's the equation, and this is a differential equation. So you separate them like this, and then, 1 over T minus Ta becomes ln T minus Ta equals Kt plus C, right? And so therefore, T minus Ta is e to the power of Kt plus C. So what I did is I shifted the TA, and the e to the power of c, instead of e to the power of c is a constant, so I use just a, right? You could say p or whatever you like, so I just use a. So I complete this equation, and then this is a simultaneous equation, right? So you plug 30 into t, small t I mean, you get this. So that means ae to the power of 30k is 32. And when you plug 60 1 hour later, you get that. So in other words, ae to the power of 60t equals 12. So between these two, so you divide to get rid of a. So we tackle k first. So it turns out e to the power of 30t is a 3/8. And hold on, it's not t. I said wrong. It should be k, isn't it? Yeah, right. And hence the 30k is ln 3/8. So hence k is minus 0.0327. I recommend that you write, you have the sensible uh, to rounding. I made like a 4 decimal places. Um, and then back to 1 to find a. So if you plug this into either one of these equations, you get a is 85.35. So the question is finding a, right? So initial temperature, because when t is 0, you just get a, isn't it? Is it? Hold on, double check. Ah, no, because when this is the equation, now when you plug 0, you get a plus ta. I forgot. You have to add 8 in. A is there. So temperature is that one plus 8 in, right? Ambient temperature, I forgot. So which is 90. What? 85.35. Hmm. Um, so boiling temperature over the is the answer. Okay, I'm gonna double check this. Yeah. All right. I will see you with complex numbers next time. Bye.